Hello, I'm Mr. Mailer, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on right triangle trig, and in particular we're going to look at special right triangles. So if you like this video, smash the like button, subscribe, and let's go. And also, if you stick around to the end, you'll get a fun picture. So, special right triangles, what are they? They refer to angles in these particular right triangles we think are nice. So the first right triangle we think of as nice is one with an angle measurement of 45 degrees, 45 degrees, and 90 degrees. So it roughly looks like this picture here I have drawn. The second special right triangle has angle measurements 30 degrees, 60 degrees, and 90 degrees. And it looks like this second picture. So what makes these nice is we know general patterns in how the side lengths of these triangles relate to each other. So 45, 45, 90 triangle. Why is this nice? Well, it turns out both leg lengths in your 45, 45, 90 triangle are the same. So if they're both the same length, then if we call that x, the hypotenuse will be just whatever that leg length is times the square root of 2. This can be proven fairly easily with the Pythagorean theorem. So you can check this for yourself if you forget the rule. The rules for our 30, 60, 90 triangle are a little bit trickier. What I recommend doing is starting by calling the shortest side length of your triangle, the one opposite 30 degrees, as x. Because if you know that leg length, the longer leg will just be your short leg length times the square root of 3, and your hypotenuse will be that short leg length times 2. So you still have a nice pattern here in your 30, 60, 90 triangle. It's just a little bit trickier to see. Now let's look at examples of how we can solve triangles with these rules. So here I have a 30, 60, 90 triangle with a hypotenuse of 7. So how do I like to start going about these problems? I like to draw a similar special right triangle with the general labels next to it. So that's what I've done here. You can see I've oriented it so it matches exactly to the one I'm trying to solve. That will help you because the next thing I recommend doing is match the side you know to its picture corresponding side in the general triangle. So in this case, I know the hypotenuse is 7 in the triangle I'm trying to solve, so I will match that up with my hypotenuse in the general picture of 2x. The reason I'm going to do that is because I can set up an equation using this. So I'm going to set these two side lengths equal to each other and solve for x. All I'm really doing here is saying, hey, this scaled version of the special right triangle, what does x have to look like if I want 2x to be equal to 7? So I do that, and 2x is equal to 7. I set them equal, and I solve to get x equal to 7 halves. Once I have this, I can simply just fill in the other missing sides following the pattern. So since my x is 7 halves here, the side length that's playing the role of x in the triangle I'm trying to solve is this short one opposite 30. So that's going to mean my 7 halves goes right there on the left. And then my other leg length, that longer leg, that looks like x times the square root of 3 according to my general picture. So x is 7 halves. So 7 halves times the square root of 3 is what I have for that leg length there. And I've now solved my 30, 60, 90 triangle using my special right triangle rules. So if your teacher gives you an angle and you know you're in a special right triangle, this is a nice way to do it. But your teacher might not always be nice, and they might give you a special right triangle problem without telling you if it's a 45, 45, 90 or a 30, 60, 90. We're still going to use a similar approach. So here I've drawn my two special right triangles next to it. I'm going to rule out which one I do not want first. So when I look at this, I want to say, what do I know does not follow the pattern? So 2 root 2. Well, that looks like the 45, 45, 90 right there. But if you're not sure, just ask, hey, it definitely can't be that side length x, because if x was 2, in the 30, 60, 90, multiplying by 2 would get me the hypotenuse. So 2 times 2 is 4, hypotenuse 8 and 4. So that 2 definitely isn't playing the role of x in this picture in my 30, 60, 90. if 2 is playing the role of x root 3, then you could solve to get x is equal to 2 over root 3, but that definitely isn't going to match up when I look at this picture either. So I can rule out my 30, 60, 90. It just doesn't make sense here to figure out, okay, I really am looking at 45, 45, 90 triangle. So that means I can label my angles pretty quickly right here. So 45 degrees. And now I know my leg lengths are the same here. So, because I can just compare, 2 is playing the role of x, 2 root 2, x root 2. I really see x is equal to 2. So I can label in my last side length as 2 there. So I really did the same thing, and I've solved the triangle. So that's it. I hope you enjoyed watching. Here's a nice funny picture. So I hope you have an awesome day, and until next time.